Now let's take a look at some of the C# language syntax. We're going to start off by talking about variables and types. Variables are containers that hold data inside your code, and types represent the nature of that data. Within C#, there's a variety of built-in variable types, such as int, which represents numbers, bool, which represents a true or false value, string, which represents different kinds of text, and a GUID, which is a globally unique identifier. There are a lot of other types, and you can create your own types, but for now we're going to focus on a handful of these. When you create a variable, you can give it a name, and this is critical because that's how you reference it within your code. These names can use letters, numbers, and underscores. However, there are a few exceptions, such as they cannot begin with numbers, they can't use reserved names such as types and keywords, and they are case sensitive. So a capital name and a lowercase name are considered completely different names and will be different variables inside your code. Now let's take a look at some variables and types in action. The first thing we're doing here is we're declaring a variable called number. There's two things I want to call out. The first one is in C#, when there are lines that start with // that represent a comment in the code. You can put anything you want in comments, it's just there particularly to describe information about what's going on and is ignored by the tools that are used to build software from it. The other thing I want to call out is that at the end of statements within C#, you'll generally see a semicolon. Semicolons are used to separate all the individual statements within a portion of code, although in some cases you will use curly braces, and we'll get into that a little bit later. But what we've done here with this int number is to declare a variable of type int. Now we've called it number, but we really could have called it just about anything. Now this number by default is not initialized, which means it can't be used until we assign a value to it. And the way you assign a value to it is simply to use the equal sign. So after this line of code is run, it would assign the value of 10 to number, and number would equal 10 whenever used after this. In this case, we're using number in two places. The first thing we're doing is we're taking number and we're adding 5 to it, which is actually on the right side of the line. The second thing that happens is that value of number plus 5 is then stored back in the variable for number itself. So at the end of this line of code, number would equal 15. Now we can also initialize variables. In the case of this, where we're creating an int called sum, and we're setting it equal to number plus 5. This will initialize the sum variable to 20, but the number variable at the end of this will still be 15. Another important feature of C# we're going to cover are enums. An enum is an enumerated type. It is a predefined set of possible values, and when you create an instance of the variable, you generally set it to one of these. The Hold Em SDK has enums for a variety of features. For example, the stages represent all the different betting stages in a hand, such as the opening, the flop, the turn, and the river. The ranks represent ranks of a card, which is 2 through ace. The suits represent all the suits, hearts, diamonds, spades, and clubs. And the hands represent the different types of hands that you can have with any configuration of cards. This ranges from a high card hand all the way up through a straight flush. And there's also an enum for bet types. This represents the types of bets that are placed, whether they happen to be raises, calls, folds, or in some cases the all-in, or if you've thrown an exception, or if your bot is timed out. Don't worry too much about these. When you want to access the type, what you do is you use the name of an enum and you use what's called the dot operator in order to access the specific enumerated type within it. So let's take a look at some examples. We've created our variables of a stages type called opening stage, and we're initializing it to the opening stage. So we took stages, which is the name of the enumerated type, and we used the dot operator and accessed opening. Now you can see a few more of these kinds. For example, if we wanted to create an instance of the ace rank, or of the heart suit, or of the straight flush hand, or of the raise bet type. Now you're going to see that we generally use enums to do comparisons later on. We're going to compare to determine if we're in the state of an opening stage, or if the cards that we're working with happen to be a suit or happen to be in the 10 rank or higher. Classes are a very important concept in C# because virtually everything that runs is running from within the context of a class. A class is a more complex type. For example, if we take an int as a variable, an int really just represents a number, but a class can represent a whole variety of information, including functional methods and properties. When you're calling a method, it requires parentheses to call, sometimes with parameters, but properties do not require parentheses. You can create an instance of a type and store it in a variable. In order to create it, you'll generally use what's called the constructor method, but there are other means of creating an instance. If you're creating via a constructor, you use what's known as the new keyword, and some constructors also require parameters, which are variables that you pass to them. Methods and properties of a class are accessed using the dot operator, similar to the way that the enumerated types are accessed. And you can chain these together to access nested methods and properties. You can also create your own classes, but that's well beyond the scope of this series. Now let's take a look at some of the bare basics you'll need to understand in order to use classes. Now this code is being provided within the context of a function called getBet, and getBet took a parameter called table. That table class itself provides some properties and methods on it that we're going to call to show how to access class data within it. But for now, let's say we're going to create a GUID. You can simply create a default GUID with no initialization by creating the variable GUID myGUID, setting the equal sign to assign it to a new GUID. This isn't particularly useful in this case because that GUID will be initialized to really zeros. But if we take a more sophisticated constructor, one that has parameters, we can create a new card. And you'll notice it takes two parameters, which are a rank and a suit. In this case, the card that we're creating is an instance of the ace of hearts. Another thing we could do is we could create a new stages and initialize it to a property that exists on that table parameter that was passed into this method. So we are calling the table.stage property and using its value to set our current stages. Another thing that we can do is we can chain those dots together so that we can access from within table an object called myPlayer, and then within the myPlayer class there is an int variable called chips, or an int property I should say, and we can access it to determine how many chips myPlayer has when it's its turn to bet. Another useful thing to understand is that there is a this keyword which enables a class to access a property or method of its own when it's executing within the class itself. Some of this information is a little more complicated than you'll need to know, but we're just covering it for the sake of completeness for some of the information we're going to cover in a moment.